Hello and welcome back. I'm Barbara O'Neill, and today we're tackling a question that's on many people's minds. Do genetics cause disease? There's a lot of debate around this topic, and it's important to understand what role genetics actually play in our health. While it's true that our genes can influence our risk for certain conditions, it's not the whole story. Many studies have shown that lifestyle choices, environment, and even our diet can significantly impact whether those genetic risks turn into actual health problems. In this lecture, we'll break down the science behind genetics and disease, explore how much control we really have over our health, and discuss practical steps you can take to reduce your risk. Stay tuned to learn more about how your genes and your choices interact in the journey to better health.
In 1953, it made headlines in the newspaper. The headline said, "Secret of life had been discovered." So what caused this headline, "Secret of life had been discovered"? Two scientists, Watson and Crookes, had been able to unravel the DNA. And the DNA is the genetic code inside every cell. And we're going to be going inside the cell quite a lot this week, because I call the inside workings of the cell the CBD, Central Business District of the human body. Because when you understand how the cell works, then you understand why people get sick. And you'll also begin to understand how we can bring the healing process so that people will be well. And right inside the nucleus of the cell is the DNA. And the DNA is the genetic code that determines the colour of our eyes, the colour of our hair, our height. My father died at 92. His mother died at 99. And at 92, he didn't have a lot of grey hair. And my mother died at 51, and she didn't have grey hair. So I'm one of 5 children, and we don't have grey hair. It's in the genes. Whereas my husband, he's a couple of years younger than me, he's white, because his mother was white and his father was white by the age of 50. Nothing we can do can change the colour of our hair unless you, of course, dye it. But guess what happens a month later? your original hair colour's coming through. Nothing we can do, or nothing I can do, can change the colour of my skin, can change my height. And because it seems, and of course we know that's true, but it seems like a tiny little step to say nothing I can do can change the fact that my mother died a cripple in a wheelchair at 51 with rheumatoid arthritis, and so will I. But you've noticed that I'm not dead and I'm not a cripple in a wheelchair, and I'm way past 51. Because genetics loads the gun, but it is lifestyle that pulls the trigger. So we're all born with loaded guns. We've come to a time on planet Earth where, especially for the last 100 years, we've been exposed to so many environmental poisons. There are so many factors that can come in to affect the genes. In fact, one writer stated that parents are the genetic engineers of their children. So our lifestyle habits before we conceive have a lot to do with the gene pool that we're. So they're able to pull the DNA out. And when it's pulled out, it's about 2 meters long. And I'm sure we've all seen illustrations of the DNA. 23 chromosomes from our mother, 23 chromosomes from our father. And there's a huge amount of information in this DNA. In fact, if you were to gather all the information that's in this DNA, put it into paperback books on top of one another, it would go to the moon and back a few times. I can hardly get my mind around that information. And inside every cell, there's the DNA. And in that DNA, no matter where the cell is, it's got all the information on how to remake us. We have 100 trillion cells in the body. We have 25 trillion blood cells. The red blood cells don't have a nucleus DNA. The red blood cells are made in the bone marrow. So the 75 trillion other cells, whether it be skin cell, bone cell, pancreatic cell, brain cell, it has the DNA and it's constantly reproducing itself according to the pattern, according to the formula. What's the DNA made up of? The outside strands are made up of polysaccharides. Sounds like a complicated word, but it actually isn't. Polysaccharides just means many sugars. And everything we eat is made up of many sugars.
Polysaccharides make up the outer strands of DNA, giving it the well-known double helix shape. These sugars help keep the DNA structure intact, while the sequences inside carry the genetic instructions. The sequences are made up of 4 nucleotide bases: adenine, thymine, cytosine, and guanine. They always pair up the same way, A with T and C with G. These pairs act like a code, guiding the cell on how to build and maintain our bodies. The specific order of these bases is what makes our genetic blueprint unique, determining our physical traits and even our risks for certain diseases. This genetic code is found in every living thing, no matter how different they may seem. The structure and function of DNA are the same across all species, showing how deeply connected all life is on Earth.
So what causes damage to the DNA? Well, to know what causes damage to the DNA, I want to first show you how the new cell is made. So DNA cannot leave the nucleus of the cell. So a photocopy is made. Yes, please turn your phones off. So DNA cannot leave. It can be pulled out, but it's connected. So it makes a photocopy. Did you know that in your cell you've got a photocopy machine?
Could you back up to prior to that? I missed what you were saying.
Okay, so how's the new cell made? It's remade according to the formula, according to the cannot leave. And so a photocopy is made. And that's what RNA is. It's a photocopy of the information to make a new cell. But what's incredible about our body, if this is a cell lining the gut, and all the information is in there, how to make new cells all through the body, the only information that's released is the information for the gut. And it comes down to a little section in the cell called ribosome. And ribosome is the little factory where the new cell is made. And so RNA comes with the information. It's like the formula, the pattern, the plans. So Michael and I have 4 daughters and 4 sons. And our sons are all what we call tradies, tradesmen. We've got some landscapers, some tilers, we've got some builders, some carpenters. But before any job, what have they got to do first? They've got to have a plan. They've got to have a pattern. And before the new cell can be made, we've got to have the pattern to it, and that's what's in the DNA. And the reason why the headlines said secret of life had been discovered is because they thought now that we've unraveled the DNA, all we have to do is change it in a few areas and everyone will be well. Are we all well? No. No, because there's far more to the equation than that. And so looking at how the new cell is made, a photocopy comes down, which is RNA, comes into the little factory where the new cell is made, which is ribosome, and the first brick goes down. I'm going to explain it like building a brick wall. And the first brick maybe is methionine. And then the next brick goes down. See, these are all amino acids. Maybe it's phenylalanine. Then the next brick comes down. That maybe is tyrosine. Maybe the next brick is lysine. Can you see how these all fit into each other like jigsaw? Incredible body we live in. And then every 3 to 5 days, out pops a new, let's say, gastrointestinal tract cell. So what's happening with irritable bowel syndrome? What's with Crohn's disease, colitis? How come they don't heal, let's say in 2 weeks? We're constantly being remade. Let me show you what happens. So photocopy is made, RNA comes down to ribosome, the new cell starts to be made, maybe phenylalanine is there. Actually, I think the first one was methionine. Ready for the next one, but there's a piece of information missing. What amino acid goes in there? The piece of information is missing. There's damage in the DNA. The body's not quite sure what it's to do now, and there's a rogue cell. What's this rogue cell? This rogue cell is a breakdown from environmental poison. I can't believe how many chemicals are in what people are washing their with, what people are washing their dishes with. Many are sick through ignorance, not realising, well, the ad on the television said it was all right. Have you learnt not to trust that? So now we're up to tyrosine. Tyrosine comes along, but where does it fit? It didn't fit very well. And now we're up to lysine, and oh no, the person's protein deficient. Maybe they're eating sufficient protein, but they don't have enough hydrochloric acid to break. And we'll look at that later in the week. And so so what happens now? Another rogue cell comes along and pokes itself where it really doesn't fit very well. And every 3 to 5 days, out pops a new irritable bowel syndrome cell.
The ongoing damage from rogue cells can make it difficult for the digestive system to function properly. When these cells keep popping up, it can lead to chronic inflammation and symptoms like those seen in Crohn's disease or irritable bowel syndrome. One of the big challenges is figuring out how to support the body in repairing itself. This means not just understanding the cell-making process, but also looking at how things like diet, toxins, and overall health play a role. To tackle these issues, researchers are focused on finding ways to help the body handle damage better and prevent these conditions from worsening. This includes exploring how external factors contribute to DNA damage and how we can improve our cells' ability to repair themselves. By getting a clearer picture of these processes, we can work towards better treatments and preventive measures. The goal is to support the body in making healthy new cells and managing chronic conditions more effectively. This approach could lead to significant improvements in managing and even preventing these challenging diseases.
So what I want to look at now is what causes the damage. 92% of DNA damage, the research is showing, 92% is caused by a mineral deficiency. So how could we be mineral deficient? 40 years ago, we didn't know what kale was. We didn't know what rocket was. Notice all these greens are coming along. When I was a little girl growing up in Australia, we had lettuce. I think that's about the only green we had, lettuce. And even then, Mum threw the dark green outside, just had the sweet core. But if you noticed in the last 15 years now, we can have cos lettuce. We can have those cos hearts using all those dark green leafies. The reason I mention dark green leafies is because that's the highest source of minerals. It's dark green leafy vegetables. We should be eating dark green leafy vegetables every day. And if you don't eat dark green leafy vegetables every day, you really should have a dose of green barley. I don't know about you, I'd rather have a nice big delicious salad with a lemon and olive oil and Celtic salt and crushed garlic dressing. So not only are people not eating enough greens, enough vegetables. Vegetables are the high source of minerals, dark green kingdom. But we've got to have a look at the way they're grown. In his book, The Calcium, Thompson, he shows that 50 years ago there was twice as much minerals in the soil as there is today. And if the soil's deficient, then the plant's deficient. And if the plant's deficient, the person that eats that plant will be deficient. And it's not only the deficiency in the soil, because of the deficiency in the soil, because in and if I grow a tomato, then when that crop's finished, I never put another crop in until I fed the soil. Because that tomato plant has taken nutrients out of the soil to produce the tomato. But it takes certain nutrients out that the beetroot's not going to take out. So I always alternate a top crop, and then when that's harvested, I feed the soil, then I'll put a root crop in. It might be beetroot, it might be carrot, potatoes. So alternating, that's how we should garden. But there are farmers today that do the same again and again and again. And what they do, because it takes time to grow organically, it takes time to feed the soil. So there's something called superphosphate. I say superphosphate produces show ponies of vegetables, looks good, doesn't taste much good. Have you ever eaten a strawberry straight off the plant? The taste, when you eat a strawberry straight off the plant, ideally organic, the flavour is intense. Do you know what you're tasting? You're tasting minerals. When I was in New Zealand, I stayed on an organic farm. I was doing meetings every night, and they grow sweet potato. In New Zealand, they call it kumara. And every day we had sweet potato chips. You call them French fries, or they do it in the oven. Deep purple, beautiful. But the reason I'm telling you this is out the front yard, out the front door of the house, there was this huge apple tree with these huge apples. So every morning, just before breakfast, I would walk out, I would pick an apple and I'd say, "Thank you, Father in heaven," and bite it. Did I wash it? No need to wash it. I wash it if it's been sprayed. I wash it if it's got manure on it. I wash it if it's got dirt on it. But do you know what I'm getting? I'm getting traces of B12. Because B12 is an airborne bacteria. But the flavour was just incredible. It was just this burst of flavour. What am I tasting? Minerals. Have you ever picked an apple up from the shop? You bite it, and if you were blind, you wouldn't even know what you were eating. This has got no flavour because the soils are deficient.
In addition to soil quality and nutrient deficiencies, modern farming practices also play a big role in the mineral content of our food. Many farms use synthetic fertilisers, which add some nutrients, but often lack the full range of minerals that natural soil provides. These fertilisers can lead to imbalanced soil, which affects how nutritious our crops are. Monoculture farming, where large areas are planted with just one type of crop, can also deplete the soil of specific nutrients. When the same crop is grown over and over, it strips the soil of the same nutrients each time, making it harder to maintain soil health. Moreover, how produce is stored and transported can impact its nutritional value. Fruits and vegetables picked before they're fully ripe might not reach their full mineral potential. The longer they sit around, the more nutrients they can lose.
But not only that, not only does it cause damage in the DNA, caffeine also leaches minerals, particularly calcium and magnesium. Those two minerals are vital for the proper functioning of the heart. So a deficiency in calcium and magnesium can contribute to high blood pressure. A leaching of calcium and magnesium is weakening the bones, because that's where our supply is. What also causes a leaching of minerals is refined sugar. There's nothing wrong with a sugar cane, but if you wanted to eat sugar cane, it's going to take you about half an hour to eat 2 inches. And there's 1 metre of sugar cane for 1 teaspoon of sugar. And Coca-Cola has 10 teaspoons of sugar. What's that, 10 metres of sugar cane? No wonder it's also called a highly addictive drug. And how many, like your teas, your coffees, your Coca-Cola, I think you have Dr. Pepper, your chocolates, how many of those are a combination of these two? Then you've got a double whammy.
When it comes to the combination of caffeine and sugar, the effects on your body can be even more significant. Caffeine acts as a stimulant, increasing your heart rate and metabolism, while sugar provides a quick but short-lived energy spike. This combination can create a cycle of dependency where you crave more to maintain energy levels, leading to overconsumption. Over time, this can contribute to issues like insulin resistance, weight gain, and increased stress on your cardiovascular system. Moreover, frequent consumption of caffeinated sugary drinks can lead to dehydration. Caffeine is a diuretic, meaning it increases urine production, which can result in the loss of more water and essential minerals from your body. This further exacerbates the depletion of vital nutrients like calcium and magnesium, impacting bone health and increasing the risk of conditions such as osteoporosis. Additionally, the high acidity in these beverages can erode tooth enamel, leading to cavities and other dental issues. The combination of sugar and acid creates an environment where harmful bacteria thrive, potentially causing long-term damage to oral health. Thank you for joining me today to explore the connection between genetics and disease. I hope this discussion has given you a better understanding of how your genes and lifestyle choices interact when it comes to your health. Remember, while we can't change our genes, we have the power to make choices that support our well-being. If you found this video helpful, please give it a thumbs up and consider subscribing for more health tips and insights. Feel free to leave a comment with your thoughts or any questions you have. I'd love to hear from you. Until next time, take care of yourself and your health.